Greetings, ladies and gentlemen. Hope you are doing well. In this presentation, we want to answer this question you are seeing on the board. It is coming from travel graphs. Others say kinematics. Now, this topic, I must mention, it's a 1 in 2. That means it comes in mathematics, also in physics. So those studying or those writing mathematics, please pay attention. Also those writing physics or science, to make it general, please pay attention as well, because it's a 1 in 2. In mathematics, it's the last question. 23. Question number 23 comes from kinematics or travel graphs. The same type of questions, or maybe a bit advanced, may come in physics as well. So as we are discussing, I'm sure by the end of the video, at the end of the video, you'll be able to pick something that will be useful. So let's start and look at the question itself. The question reads, figure below shows a velocity time graph of an object moving along a straight road. So what you are seeing here is the movement of an object along a straight road. So this side here we have velocity, which is in meters per second, and then on the other side here, which is the horizontal, we have time, which is in seconds. Then we have 4 questions attached to this. Maybe before I can consider the questions, let me remind you of this. Whenever you are given a travel graph, you need to understand the meaning behind that before you consider the questions. Understand the meaning. Let me put it this way. This 0 you are seeing here indicates the starting point, which is the initial. We call it initial, the starting point. But I'm not saying always the starting point will be 0. No, it's not always that the starting point can be 0. It can also start from there, moves. You have seen such kind of graphs, isn't it? What is important is for you to know the starting point. The question I've given you here, the starting point is what? 0. That is our initial velocity. That is our initial velocity. If it is like this, then there's a 5 here. That means the starting point is what? 5 and not 0. That's the first thing. Now, what does that mean, starting point? Imagine you are on a journey to Lusaka. Let's put it that way. Traveling from where? Let's say from Kitwe. So Kitwe is your starting point. That is where we are. That's the meaning behind that. Kitwe is your starting point. When you start off by car or any mode of transport, when you start off, it means the car has started moving, and we say the car is now accelerating because there is now change in terms of time and speed, which is also velocity. So as the car is accelerating, how do we show? This is the meaning here. So this part from 0 to this point here means the car is moving. To where? To Lusaka. Are you seeing that? The car is moving. Started from where? 0 here. Then the car is moving to Lusaka. But you can agree with me that as you are going to Lusaka, there will be at a point where you need to stop and buy something. So when you stop, let's say Kabwe, you stop at that place. Are you going to stop time? Time will not be stopped. Time will still be. Are you seeing that? So to indicate that you have stopped, this is the part you are seeing here. This is the part you are seeing from this point to this point. That indicates that the car was not moving. The car was not moving. What was only moving was time. Are you seeing? At this point it was 10 seconds. Then at this point it reached 40. So time was moving. But look at the velocity here. Remained the same. When you start off, you say, okay, you buy something there, carway, then you start going. The graph will still be able to change. So let me draw it nicely here. So what I'm saying is, you are here. When you start, this is the meaning. When you see this, it means the car is moving. The car is accelerating. Change of velocity. As it is moving here, you need to stop somewhere to buy something. Let's say I'll stop at this point, and then at this point, let's say where I've stopped, this is where the 10 seconds is. Then I'll buy my things that I want, water, food, and other things. Let's say I've spent 20 minutes doing that. So I'll be able to add 20 to this, which will give me 30. So my 30 will be somewhere there. It means at this point, the car was not moving, but time was changing. So I will indicate with that. You see, up to that. This indicates that I spent 20 minutes. Then the moment I start moving, it means this. I see that. That shows that now I've continued my journey. At this point there, they say, okay, I've reached where I'm heading to. I've reached Lusaka. Have you seen that? I've reached Lusaka. Now I'm not going any further. Back to that. So when you see such kind of graphs, you need to understand the meaning behind it. Then the rest of the questions will be very simple. Very simple. So when you reach that point, you reach where your destination, where you are going, where you are heading to, then since you are not moving any further, you come to rest. It means here you are accelerating. This now is the opposite, which is called deceleration or retardation, if you have heard those two words. It means negative acceleration. This is positive acceleration, this is negative acceleration. I hope that will be able to help you answer questions. Of course, you might find different diagrams, but the meaning behind those diagrams remains the same. Now let's look at the questions that have been presented here. The first question, first part here says, what is the total time for the journey? Look at the diagram. Tell me, what was the total time for this journey? Started from 0. At this point, this person decided to rest when it was 10 minutes. The person rested for how long? From 10 went to 40, so meaning the person rested for 30 seconds, then it came to rest here after this 50. So we are saying, what is the total time for the journey? The last number is the total time, which is in 50. This is where the journey came to rest. So you just say 50 seconds. That that is the total time. They can ask you a lot of questions in different ways. They can even ask you to find this t here. Okay, they can ask you to find this v here, provided you have enough information presented before you. Everything becomes easy. So that's the first part. Second part, what is the maximum velocity for the journey? What is the maximum velocity for the journey? Well, velocity is this side. This time you will be able to find time, then this side velocity. If not velocity, then there will be speed. Remember, velocity and speed are the same, except that velocity is a vector quantity while speed is a scalar quantity. So, when we have velocity here, we are told to say what is the maximum, the highest, okay, for this car. So the car went up to this. This is the maximum of the height, which is 10. Don't forget to include the units. And this will be 10 meters per second. This is the correct answer for that. We look at C. What is the acceleration during the first part of the journey? This is where you need to understand. During the first part of the journey. So we have the first part here where the car did not stop. That's the first part until this person decided to rest at this point. So what we want is the acceleration that this person took in the first journey. So this is what we are talking about here, the first journey. The acceleration has got a formula that you need to know. This formula is written this way. Acceleration is always equal to small letter a, which is always equal to v minus u over t. That's why when defining acceleration, we say acceleration is the rate of change of velocity. Okay, the change of velocity, that is what gives acceleration. So we are now saying acceleration is equal to the v here stands for the final velocity, then the u is for initial velocity, where the journey started from. Then of course we have time in seconds. What was the final velocity? We come to this. Up to this point, the velocity is here. So the final velocity 10 minus initial velocity started from 0. So we have 0 here over what was the time during the first part of the journey. So the time here is 10 here. So we have 10 as the first. So we have 10 there. So when we divide the two, we are going to have acceleration will be equal to 10 into 10. So we have 10 divided by 10. Our acceleration will be 1 meters per second squared. This is what we have as our acceleration. Ends there. Okay? Now, the other part here now. This is where you have to pay attention. Where it says, calculate the total distance covered by the car. What is the total distance covered by the car? Okay? In this case, when they say you should find the total distance, please pay attention. You are going to look at the graph that you have been given. When you look at that graph, then the total distance will be the area under that graph, or the area for that graph or shape. Let's put it that way. Of course, the one you are seeing here, I'm not saying it's always the same. No. you can have different shapes. But when they say you find the total distance of the journey, you are going to consider the shape. After considering that shape, you are now going to find the area of that shape. Two ways of finding the area. If you look at this shape here, what shape is this? This is a trapezium. So, since this is a trapezium, I will be able to say area of the trapezium is, the formula is always equal to half A plus B H. That's the area of the trapezium, which is this shape here. If you don't want to go in that way, for example, if you have forgotten the area of the trapezium, what do? You can still partition the shape. You'll still be able to find the same answer. What do I mean by that? You'll be cutting the shape and then you add everything at the end. Look at this. The first part here. What is this shape? This is a triangle. So you're going to write the area of this triangle. Then the next shape I can see here is this one here. This one here. Listen this. This looks like rectangle. Others might see it as square. But again, that will depend with the measurement that we are going to have. If they will be equal here, then we'll conclude to say, okay, this is the square. But if we see that this measurement is not equal to that, then it's a rectangle. Have you seen that? Then I'll write the area of that rectangle. Then I also have the last one here. What is this? A triangle. So I have 1, 2, 3. I'll add them. So I've got 2 triangles. So I'll say total area in that case will be, the first one is the triangle, and the triangle is BH, half BH, plus number 2 here, let's say it's a rectangle. So I'll say plus L times B, that is the area of a rectangle, plus the last one is what? Is a triangle. So 1/2 BH. See that? Then I'll start substituting and get the answer. The answer I'll get here will be the same as the one who has used this. I'm bringing this because it's not always that you'll be able to find the shape that will just be one, like a trapezium. No, it can be a trapezium, then there are also other shapes. So in that case, what is important, or what you need to know, is when we say total distance that was covered by the journey, we are talking about the area of the shape that you've been given. So the shape can be the same, or can be just one trapezium, or they can be trapezium and other shapes. What is important is for you to add them and find the final answer. So in this case, let's just go straight to the formula, the first one there, instead of using that. So we're going to say area is equal to half. What is my AB? So in a trapezium, A and B are 2 parallel lines or sides. Those that are parallel, A and B. That's the meaning. So look at this. We have this line here parallel to this. So this is where A and B is. So this can be A, this can be your B. Okay? Then the H here is for the height, meaning from this to that. We substitute. What is our A? My A is from this point here to this point. Right? So this point is 10, then this point here is 40. So do not write 40. We are looking at this length here, this. So 10 to 40. That means I'll say 40, take away 10, and this will be 30. So from this to this is 30. So this is 30 here. So say 30 plus, what is my B? B is from this point here to the end. We are talking about the total journey, okay? So from here to this, that is from 0 to 50, that gives me 50. Then my height here is from this point to this point. So from this to this is 10. So you write here 10. Then we can do the mathematics behind this. So I can reduce this half, which is 2 into 2, 1. 2 into 10 gives me 5. Then I can add these two in brackets here. I'm going to have 80. So I'll say 80 times 5. And this will give me 400. Okay? So now we are talking about what? Distance here. You are not going to put the units for area. No. We use area to find total distance. So in short now we are going to say, therefore, let me just say here, therefore distance will be equal to 400. What are the units? There's meters here, so 400 meters. 400 meters. That is the answer. I thought of sharing this with you, ladies and gentlemen. Thank you very much for watching. Keep studying.